Namaskar friends. In last lecture, we have discussed the revisiting irrational numbers, right? And some irrational numbers are given here in our textbook. Look here, root 2, root 3, root 15, pi, minus root 2 upon root 3, and 0.10, 110, 1110, 4 times 10, etc. All are irrational number, right? This one say non-terminating irrational number. Non-terminating. You have studied this type of sums in 9th standard also. I think in your textbook, last exercise, this type of question are given. Look here, exercise number 1.4, last exercise, and check here. Yeah, look this question. 0.120, 1200, 12000, 124 times 0, etc. Dash, dash, dash. Right? This one is non-terminating recurring irrational number because you cannot convert the P upon Q form. Now read your question. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. First question, this one. So here the second question here, question 3 second. This one is not a rational number. It is called irrational number, non-terminating irrational number. If they are rational, so here our sum completed. Because this number is not a rational number, irrational number, so we can't calculate here, continue. Okay, now we discuss first question and third question. Both are same question, and first question is very easy. See, you can convert simple decimal expansion, not here dash 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 here, last one, right? So simply convert decimal expansion. After decimal, how many digits? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 upon 3, 6 and 9 digits. 90. Is that clear? Now, up to this question completed, rational. If they are rational and of the form P upon Q, here we convert the question numerator P, denominator Q, right? Now, what can you say about the prime factor of Q? Now we discuss the only denominator, not numerator. Numerator already give the answer. Numerator not can change here, but denominator total 90, so you can convert 2 into 5 power 9. 2 5s are 10, 10 raised to 9, that means 90, right? So here numerator as it is and denominator convert 2 raised to 9 into 5 raised to 9. Is that clear? Okay, so denominator you can say about what about say prime factorization of Q. So here the denominator we can convert the prime factorization 2 and 5. Is that clear? Now third question you have studied already in 9th standard. We have in this calculation same to same 9th standard, right? Now look here. This question we discuss in next lecture, but here we write here question because now look here. We calculate question. Yeah. Now here we write the question here. Which question? 43.12129. Okay. 43 point 43 point, yeah, 1 2 3 4 5 6 7 8 and 9, right? Here we suppose this first one bar sign. Yeah, now convert the number in simple form. 43.1 2 3 4 5 6 7 8 9. Again 1 2 3 4 5 6 7 8 9. You can write also again. Okay, here we suppose this number is say x, right? It is called also 1x also. Is that clear? Okay. So after the decimal, 9 digit can be repeated here. Right? 9 digit, 1 to 9 digit be repeated. So here multiply by both side 9 times 0. Multiplying both the side 9 times 0. Multiply left side first one. 1, 2, 3. Just hold it. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 0. Now right side multiply by 9 times 0. So decimal, jump the 9 digit here. Okay, so 43, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then again 1, 2, 3, 4, 5, 6, 7, 8, and 9. Clear? Now subtract the original number from this number. Subtract the original number from this number. Now write here 1x. We write here 1x equal to 43.1234567 and 9. Okay, so you can write here 0, 0, 0, 0, 0, 0, 0, 0, and here place here 0. Now subtract here. Right? So after the decimal, same number. So compulsory here all the zeros. Right? Okay. Now 9 minus 3, 6. 8 minus 4, 4. And all the digits are remaining as it is. 7, 6, 5, 4, 3, 2, 1, 3, and 4. And here x as it is. Now 10 minus 1, 9. And all the 9 zeros. 1, 2, 3. Look here. 1, 2, 3. Then again 1, 2, 3. 1, 2, 3. And here 0, 9, 9, and here 0. Is that clear? Now you can convert simple P upon Q form, otherwise A upon B form. Right now, write this number in denominator here. Here we discuss. So x equal to 4, 3, 1, 2, 3, 4, 5, 6, 7, 4, 6. Divided by how many times 9? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. 1, 2, 3, 4, 5, 6, 7, 8, and 9 times. Now, here possible or not possible, I don't know. You can divide 3 or 9 also. Otherwise, this is your final answer. Here we convert the P upon Q form. But our question is what? Our question is, look, read this question. The following real numbers have decimal expansion is given below. In each case, decide whether they are rational or not. So first we decide the rational. Right? Because here we convert the number P upon Q form. Right? If they are rational, remember here. Remember, if they are rational and of the form P upon Q, what can you say about the prime factorization of Q? So, but here in denominator, we can't convert the prime factorization of 2 and 5 because here not here 0 present. Right? We convert the P upon Q form, but we can't convertize denominator the P upon Q. That means 2 into 5 prime factorization method. Is that clear? Okay, again repeat the question. Here, rational or not? So answer rational. Because we convert the rational and of the form P upon Q. Yeah, here complete question. But one more question. What can you say about the prime factorization of Q? So here denominator, we can't convert the prime factorization number, right? Okay, how is it possible? Otherwise you can convert divided by 3 or 9. Try it here. You can divide 3 or 9. Suppose, try it. Any number 3 or 9. You can try also, right? Is that clear, student? Okay. Now we discuss one more theorem. Is very important theorem. I think theorem number 1.3 is remaining here. Just here we look here. Yeah. Theorem number 1.3. Most IMP. Most IMP. First we read the statement. Let P be a prime number. P be a prime number. If P divides A square, then also P divides A, where A is a positive integer. Now you can select any positive integer. Any positive integer. Here we select the positive integer. Suppose A equal to 12. Suppose A equal to 12. Here we suppose. Look here. A equal to 12. Suppose. Right? Here if P divides A square, then P divides A. So first we suppose A. So A equal to 12. Here we suppose A equal to 12. We can calculate also. Look here. We can calculate. Easy. Suppose A equal to 12. We can choose here number. Now factorize here 12. So 2, 2s are 4. You can select any number, any positive integer. Right? Okay. Now look at your textbook. Let P be a prime number. If P divides A square, then P divides A. So here A equal to, we choose here A equal to 12. So this one say prime factorization, right? Okay, you can write also here A equal to 12, and here the factorization 2 2s are 4, 3s are 12, right? Now look here, proof here. Not asking your examination, only for explanation. Before in next lecture we discuss this type of, above this theorem we use the example, right? Let the prime factorization A be as follows. A equal to P1, P2 up to Pn, where P1, P2 are prime number. Look here. Here A equal to 12. And this one say prime number P1, P2, P3. Right? P1, P2, P3 all are the prime. Not, this is the most important statement, not necessarily all are distinct. Look here. Here P1 and P2 are same. Yeah, you can choose any other number also. Right? Suppose we can select 72. We can select 72. So factorize here 72 9 8s are. So 2 into 2 into 2. Right? And 3 into 3. Okay. So here the P1, P2 and P3 are same. And P4 and P4 are same. Is that clear? So here the most important statement, not necessarily all are the number are distinct. Right? Now square the number. Square this number. So A square equal to P1, P2 up to Pn. Again multiply by P1 into P2 up to Pn. So you can write directly also P1 square, P2 square and Pn square. Here we can direct square in both the side. So left side A square is A square and P1 square is P1 square, P2 square up to Pn square. Is that clear? Now, but read your question. Read your question here. P divide A square. This is our data. P divide A square. Now read your statement. We are given that P divide A square. Therefore, from the fundamental theorem of arithmetic, it follows that P is one of the prime factor of A square. This is the most important statement. Because here P divide A square. So P is one of the prime factor of A square. That means A square is divisible by P. A square is divisible by P. Right? So however, using the uniqueness part of the fundamental theorem of arithmetic, we realize that only the prime factor of a square are p1, p2 up to pn. Here we already write here a square in factorization this one, right? P1, P2 up to Pn. But our data, P is one of the prime factor. So P is one of any one, P1, P2, otherwise P3, otherwise Pn. Is that clear? Now here we discuss the example. Look here example, a equal to 12. We convert the prime factorization, 2 into 2 into 3. Now square of 12. Square here, 112 square is 144. Now you can repeat the number, 2 into 2 into 3. Again 2 into 2 into 3. Is that clear? Suppose 144 is divisible by 2, right? Okay, so 144 is divisible by 2. So 12 is also divisible by 2, right? So here 2 is the one of the factor of 144 and also 2 is one of the factor of 12 also. So exactly same here. However, using the uniqueness part of fundamental theorem of arithmetic, we realize that only a prime factor of a square is p1, p2 up to pn. So p is one of the p1, p2 up to pn. So you can say any number, say p. Any one of the numbers, say p. Right? So here a equal to p1, p2 up to pn, where p divides a. Is that clear, student? Very easy. Again we repeat the number here. Let's repeat. The most important. Right? Okay. P be a prime number. Here we p equal to, suppose this one is erase here. 72 erase here. Yeah, not necessary here. Okay, we can suppose here only and only 12, right? Okay, look here. Yeah, here we suppose a equal to 12. Okay, p be a prime number. So we take, and if p divide a square, then p divides a, where a is a positive integer. So first we suppose a is a prime number. Here we suppose 12 is a prime number, right? We factorize, prime factorize. 12 is a prime number? No. 12 is, we select any positive number. Yeah. A is any positive integer. We convert the prime factorization, 2 into 2 into 3. Now square of the 12 is 144. So 144 factors, 2 into 2 into 3 into 2 into 2 into 2. Yeah, very simple. Now here 144 divided by, suppose 2, right? 144 divided by 2. That means 2 is one of the factor of 144. That means a square. That means a square, right? So exactly now reverse here. So 2 is also one of the factor of 12. That means 2 is one of the factor of a. That means a is divisible by 2, right? So same calculate here. Same exactly calculation, right? Is that clear? So theorem number 1.3 is very important, but not asked in your examination. But this theorem we use the another sum also. Is that clear? Okay. Thank you very much, student. Here the lecture completed. Okay.